Professor Navarra. In your view, which role can carbon dioxide removal policies play in climate stabilization, and how carbon dioxide removal technologies deployment may affect the future of international climate policies?
Well, I think that at this point in the whole history of climate change, we probably have come to the realization that the problem is difficult, is hard, and it's hard both from a technical point of view, from a scientific point of view, from a political and social point of view. Being confronted with such a complex and difficult task, then I think it is reasonable that we start to look for every possible initiative or technology or policy or method that could help us in this difficult passage. So CDR, direct removal of carbon dioxide from the atmosphere, looks like one of the things that we at least have to consider and try to see if there are viable technology for at least contribute to partially to sort to solve this problem. I think that there will be, well, first of all, we have to establish if they're feasible, if they work, how much they cost, all this kind of, in a way, due diligence that we have to do for emerging technologies. But I think that in the end, that will probably result to be one of the arsenal of measures and initiative and things that we'll have to deploy in order to tackle climate change.
And do you see any synergy or trade-off between CDR technologies and other existing mitigation options or other development policies and opportunities, such as in CCS, the use of land for food production versus biodiversity conservation, forest conservation?
Well, I think one of the attractive things of CDR is the fact that they will reduce carbon dioxide wherever you put them. And so they, in a way, they're perfectly suited to reduce carbon dioxide from distributed sources that are notoriously difficult to tackle, and for which we don't really have sort of a silver bullet policy like CCS that works very well for localized, intense carbon dioxide streams, but of course it wouldn't work for an automobile or a train. So in this sense, they're very attractive. I think synergies will emerge. The important, so early in the development of the new technology, I think the most important thing is to let people think creatively and interact with different fields, because synergy will emerge as long as the development of the technology will progress and people will be tackling issues like cost and efficiency, and in a way will be forced to consider synergies in order to make the whole process more efficient.
And based on your knowledge, among existing CDR options, which ones are more environmentally sustainable?
Oh, that is a really difficult question. I'm not an expert, so I can't really say, but just gut feeling, I think that probably the most attractive is the least developed and the most, in a way, risky of all the CDR technology. That's one that's based on the accelerated weatherization of silica, because that produces, in a way, removes all the other technology will end up with some liquid carbon dioxide that you'll have to store somewhere, exactly like CCS. So in a way, you're still facing then the problem of localization, acceptability by the social public, by the public, and so on. In that technology, instead, the final outcome is basically solid rocks, and so in this way, you can have an easier time in finding a suitable storage site.
Do you believe that the accident of Fukushima will have an impact on future energy and climate policies worldwide, and in which way it may call for more CDR, investments in CDR or other sources of energy such as renewable?
I think Fukushima has shown in a very deep way the need for a transparent and timely management of environmental crisis like this. I think the main problem with Fukushima is, of course, the problem with radiation and technology also, but I think there is a a wider reaching effect of Fukushima that is making less credible authority and also scientific authority when they're faced by questions from the public regarding safety of large, complex, basically non-understandable technological endeavor that common people cannot really relate to easily. In this case, were nuclear plants, but I expect that we may have the same problem with large installation like CCS installation, or even large wind or photovoltaic farms that are going to be perceived by the public in a similar way, like large, complex, in a way alien technology that will be imposed on community, and without a proper preparation and discussion and debate and engagement of these communities, will be really difficult to let these major projects be accepted.
Climate finance is limited, and international financial markets may not be able to provide the resources needed to support this transition to a low carbon world. So given these limited resources, in your view, which technological improvements are mostly needed, where resources should be directed to in research and development and technological innovation?
Well, I would sort of divide. I mean, as you know, I mean, the public resources should be invested on technology that are far away from the market, and private resources should be mobilized for applications that are close to the market. So I think that divisions more or less have to be dealt with in a different way. In the first case, it's an issue really of, in a way, something that we know very well. That's how you prepare the programs of the public research funding and programs. And of course, there's a lot of lobbying and pushing and elbow pushing here and there. But in the end, we know that there are a number of priorities will emerge from the scientific community that usually are a trade-off between what is doable and what is desirable, and in the end, usually the program are sensible. For the second part, I think we have to find the right set of incentives that will mobilize private funds so that they will be applied to these kind of problems in the future, and this is, of course, is a job for economists and modelers and policymakers to find the right mix. But let me stress that it is in a way amazing that not only in poetical terms the fate of the planet, but also the amount of resources that are being moved, that are revolving around the climate change problem, that usually are just some number too big to be mentioned because it's just some enormous number. Nevertheless, they rely on the scientific works of a very small community of people that is systematically underfunded. And this is really strange. One might think that if you are faced with a really difficult problem, the first thing you want to know is, do we know enough of this problem? How good is our knowledge? What are the limits of our knowledge? And therefore, I would say that probably even doubling the present budget for research and basic research in climate change would still be a minor dent in the enormous amount of money that are moved by the downstream effects of this research. So I would say there is room for improvement there.
Okay. And what is your view on the evolution of climate policies on the way to Durban and beyond Durban?
I'm always optimistic because I think we have to be optimistic, but I'm optimistic also for other reasons. That I think that in a way, humans have a way of always having solved problems once they really become sort of convinced and aware of it. And regardless of what we may think, the climate change problem is on the table. It's not going to go away. Even people that claims that it's not there, they're actually talking about climate change. So I think sooner or later we'll fix it. On the other hand, it's not always so, because humans not always follow with a rational decision a rational awareness of a situation. I mean, a lot of people still smoke, so if you ask them if they know what it means, they probably know everything. Nevertheless, they don't stop. So there is aspects of human characters that leads me to some concern. So I would say we should be optimistic but concerned.
Thank you. Grazie mille.
Yeah.